Hello students, myself Harish B, Associate Professor in Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. In the last session, we have discussed about the basic things of the subject that is called as Engineering Graphics with the subject code 18 EGDL 15/25. So with that basic things, just to recall, so we can have 4 different quadrants. So first, second, third and fourth. So we'll be starting with the first model, that is projection of points. So here, in case of projection of points, a point can be placed in all the 4 quadrants. So this is how our quadrants will be. This is the first quadrant, second, third and fourth. This is horizontal plane, this is the vertical plane, this is the horizontal, this is the vertical plane. So first quadrant, second quadrant, third quadrant and fourth quadrant, that is what written here. Now here, before going to the actual problems, so just to recall where will be the top view and front view in case of each quadrants. So top view is the view what we get when you look from the top. If you consider this as the plane, if the object is in this plane, so if I look from the top, the view what I get will be top view. Similarly, the same object can be viewed from the front, so what I get will be called as front view. So where will be the top view and front view for each of the quadrants? So in the first quadrant, so front view will be always above XY line, top view will be always below XY line. So these are the basic things should be remembered before going with the actual problems. So first quadrant, so front view will be above XY line and top view will be below XY line. So one more thing that has to be known is that always the horizontal plane will be rotated, vertical plane will be fixed. Come to the first quadrant. So this is the first quadrant. So object is there here. So vertical plane fixed, horizontal plane will be always rotated clockwise. So very important, horizontal plane will be rotated, vertical plane will be always fixed. So first quadrant, so if the object is here, so if the observer is looking from this side, so that is the view what we get is called as front view. So if the observer is looking from the top, what view we get is called as top view. So horizontal plane rotated clockwise. The intersection of this horizontal and vertical plane is called as XY line. Intersection of this horizontal vertical plane is XY line. So here will be the front will be above XY line. So if it is like this, it is rotated. So observer looking from this side, so front view is here, top view is here, so rotated, front view above, top view below. That is first quadrant. Second quadrant, so this is the second quadrant. So second quadrant, so once again the object can be placed here. So how will be the position? So both top and front view will be, that is your above XY line. So same thing. So this is the second quadrant. So rule, the horizontal plane is rotated, vertical plane is fixed, object is here. So looking from the observer side, front view is here, top view will be, looking from the top, top view will be here. So rule, so horizontal plane will be rotated. So when you rotate like this, both top and front view will be above XY line. Intersection of horizontal vertical plane is your XY line. So second quadrant, both top and front view will be above XY line. Then come to the third quadrant. So this is the third quadrant. This is the third quadrant. So here, once again, object is here. So top view will be here, front view will be here. So rule, once again, the horizontal plane is rotated, vertical plane is fixed. It will rotate it like this. So it is just third quadrant, just opposite to first quadrant. So front view will be below XY line, top view will be above XY line. So fourth quadrant, so this is the fourth quadrant. So object is here. So rule, only the horizontal plane is rotated. So in this case, both front view and top view will be below XY line, vertical plane fixed. I am rotating horizontal plane. So both top and front view will be above XY line. This the intersection is your XY line. So these are the basic things should be known before going to the actual problem. So coming to the projection of points. So here we consider the point to be in all the 4 quadrants. Based on the given condition, I will be drawing the projection. So here different varieties of problems can be asked. So we'll start with one variety of problem. So the problem runs like this. Draw the projections of the following points on the same XY line, keeping convenient distance between each projectors and also name the coordinates in which the point lie. So 4 points are given. So A, B, C and D. So the position of all the points are given. So I have to draw projections for those conditions or for those points satisfying the condition given. So what it says that draw the projections of the points on the same xy line. So xy line will be same common xy line and keeping convenient distance between each projectors and name the coordinate. So coming to the first point. So point A. So one more thing that has to be noted down is here. So given in the problem, always capital letters will be used for representing the point, while drawing the projections it will be a small case letter. So for front view it will be dash, for top view it will be just the letter, small case letter. First point, so 30 mm above HP and 35 mm in front of VP. So how to draw the projections. So first coordinate, so 30 mm above HP, 35 mm in front of VP. So top is here, front view is here. I know first coordinate, that is front view will be above xy line, top view will be below xy line. So how will be the solution or how to draw the projections? So rule says that vertical plane is fixed, horizontal plane is rotated like this. So 30 mm above, 35 mm in front of, that is VP. So in front of VP and 30 mm above. So my front view is here, top view is here. I will be rotating horizontal plane clockwise. So rotating horizontal plane clockwise. So when that is the case, so I will get the top view is below, front view is above. How to draw the projections? So first I will draw the xy line, then I will measure a distance of 30 mm above, that is your xy line, 35 mm below. So why 30 and why 35 mm? So the problem says that 30 mm above HP and 35 in front of VP. Above HP, in front of VP. So this 35 mm, so what is in front? So that will be projected on your, that is horizontal plane. That comes below xy line. And 30 mm above HP. So this 30 mm above HP is somewhere here. This is the distance 30 mm. So looking from the observer, so that is projected here on the vertical plane. So that's what done here. So from xy line, you measure distance of 30 mm. So locate the point position here. Then draw a projector. These are called as projector lines. So these are called as projector lines. Projector lines. So measure distance of 30 mm above. So then here one more thing that has to be noted is that front view and top view will be always in line. So front view and top view will be always in line when you draw the projections. From here you measure 30, then below 35 mm you measure distance of 35 mm. So draw the point position there. So projection of point A. So here and here. Then this is A and this A. So front view, as I just now told, front view will be represented as dash, that is A dash, and this is A. Then show the dimensions. So these are called as extension lines. So here this is also extension line. So from the projector you draw an horizontal line that will parallel to xy line, that is called as extension line. So there draw the arrow mark to show the dimension. So arrow tip should be touching your xy line and this extension line. This distance is 30 given and this distance is 35 mm. So this is how you draw projections for the first point, that is 30 mm above HP and 35 mm in front of VP. Next come to the second point. So it says that 35 mm above HP and 40 mm behind VP. So once you read the problem, immediately you should analyze in which quadrant it lies. So these things should be very much familiar. So once you read the problem, 35 mm above HP, 40 mm behind VP. So immediately you should imagine where will be the point, in which quadrant. So in this case the point will be in second quadrant. So for second quadrant it is known that both top and front view will be above xy line. This is the position, second quadrant. So it says that 35 mm above HP and 40 mm behind VP. This 40, this 35. So rule says that horizontal plane rotated above. So both your top and front view will be below your, that is above your xy line. So xy line is the intersection of your horizontal and vertical plane. Now how to draw the projections? So here you can see that one more thing here it is mentioned as that taking convenient distance between each projectors. That is, this is one projector, this is second projector, third projector, fourth projector, since I am drawing the projection of 4 points. So from this projector to this projector, you take any convenient distance. That should be same throughout the problem. So measure convenient distance. From here, you measure distance of 40 mm and a measure distance of 30 mm. So there you locate first point B, and this is B. This also let it be initially B, and then we can, in the later stage, we will analyze whether it's top or front view. Based on that, if it is front view, it should be dash. If it is top view, it will be just a small case letter. So measure distance of 30 and 35 and 40 mm. Then locate point B here. It should be small case letter. Then here, as you observe here, from the given problem, 35 mm above HP and 40 mm behind VP. So this is 35, this is behind VP. So this 40 mm behind VP, so that will be corresponding to your horizontal plane. This above will be corresponding to your vertical plane. So when you rotate it, you get this XY line. So distance of 40 will be, it is your top view, whereas 35 will be front view. So here, in case of graphics, imagination should be there. So how will be the position? So basic things, if you are perfect, so then analyzing the problem and drawing the solution will be more easier. So second quadrant, so it says that 35 mm above HP, this distance 35, this is 40. So if you are looking from this side is the observer, so this is 40, this is 30. So horizontal plane is rotated, so this is 40 and this is 35 mm. So you should identify which is the front view, which is the top view. So this 35 distance, so here 35 mm above HP, so 35 mm above HP, so you are looking from this side, this 35 mm will be your front view observer. So this 40 will be the with respect to top view, hence this is B dash and this is represented as B. This is the front view, this is the top view. Then come to the third point. So it says 40 mm above HP and on VP. So here, if the above HP on VP says that. So here it is above HP and on VP. It can be front or it can be behind. That is not mentioned here. So it is above HP and on VP. So it can be here or it can be in front of vertical plane or it can be behind vertical plane. Rule what says that? Rotate the horizontal plane like this. So it says that 40 mm above HP, 40 mm above HP. So this 40 will be corresponding, if you are the observer, it will be corresponding to a front view. So front view, you measure distance of 40 mm from XY line. So this is C dash because it is front view. So whereas other point will be on VP, it's telling that is given in the problem, that is on VP. So since it is on VP, if you look from the top, if the point is here, if you look from the top, it will be projected on your XY line. It will be projected on your XY line. It can be front or it can be behind. So that is not mentioned. But why projection will be on XY line. So from here, you draw vertical projector. So this is the point, that is C, that is the top view, and this is C dash. Then come to the last one, 35 mm below HP and it is in front of VP. Below HP in front of VP. So it is below HP, this is below HP in front of VP. So here look, note down distance 35 mm, this is 35 mm below, this is it is 30 mm in front. So this 35 mm below and 30 mm in front. So looking at the observer, you have to locate the top and front view. From here you draw a projector, measure distance of 30 and 35 mm. So here once again looking at the quadrant, so this will be D dash, point is given as D dash because it is front view, this is point D. So this is how we can draw the projections of the given point. So here the other way the problem can be asked is here I am representing 4 different points on common XY line. So the other way problem can be asked is just one particular point given. So forget about all these points. So only point, take the point A dash, that is 30 mm above HP and 35 mm in front of VP. That will be the problem. Like that, it can be in any of the quadrants. That is one more variety of the problem can be asked. So here I have taken this problem to show both the ways how the problem can be asked. Now here one more thing that is left out is name the quadrants in which they lie. So once you draw the projections, the second part is that you have to name the quadrants. So 4 points are there, A, B, C and D. So look at the point A. So front view is above, top view is below XY line. So as per the convention, so it will be front view above XY line, top view below XY line. So then you can come to the conclusion that point A is in first quadrant. So that is what point A is in first quadrant. Come to the second point. So second point is that your both top and front view is above XY line. So whenever the point is in second quadrant only, we can come across this type of condition where top view and front view will be above XY line. Since it is above, both are above XY line, point B is in second quadrant. Come to the third point. So this is once again not a regular case. So where the top view is on XY line, front view is above XY line. So here it can be first or second quadrant. How? So it is telling that point is given on VP, so it can be here in front or it can be behind. So if you take in front, it will be in first quadrant. If you consider to be behind, it will be second quadrant. Hence points is in first or second quadrant. Then come to the fourth one, both top and front view is below XY line, just opposite to second quadrant. Hence the point D is in fourth quadrant. So this is how we can draw the projections for the given problem where we have got 4 points A, B, C and D. So we'll go to the next problem. So problem runs like this. Draw all the views of a point P lying 60 mm below HP, 70 mm in front of VP and 40 mm from RPP. So right profile plane. RPP is nothing but right profile plane. Also state the quadrants in which it lies. In the previous problem, we had drawn projections where we had drawn top and front view. Now object or point can be viewed from the sides also. So it can be looking from the right side or looking from the left side. The view what we get is called a side view. So in the previous problem we discussed about the top view and front view. So a point can be viewed looking from the right side or from the left side. So the view what we get or the projections what we draw is called as side views. So here how will be the position? So if you take the first quadrant, so if this is the first quadrant, so we know that the point is here somewhere here above HP in front of VP. So I can have one more plane like this, one more plane like this. So this is where my side view will be projected. If you want to draw the projections, you should have a plane. So previous case we have got two planes, horizontal plane and vertical plane. So in order to draw the profile view or side view, I should have one more plane that is called as profile plane. Now if you take this as the first quadrant, so this horizontal plane, this is the vertical plane and this is the profile plane, it will be like this, it will be like this. Now the intersection of your horizontal and vertical plane is XY line, that is what we have seen in the previous problem. Intersection of horizontal plane and vertical plane is your XY line. Similarly, if you have one more plane, I will be having intersection of this profile plane with respect to this vertical plane. So how will be how to draw the projections? So if it is only for top and front view, so rule is that horizontal plane is rotated clockwise. Horizontal plane is rotated clockwise. If you have got one more plane, this is how it will be. So horizontal plane is rotated clockwise, you will get down. So this is profile plane, this will be opened outward. This will open outward. Then you have intersection of this profile plane and vertical plane. So intersection of profile plane and vertical plane is called, or it will be represented as X1 Y1 line. Whereas intersection of your vertical plane and horizontal plane is XY line. Intersection of your vertical plane and profile plane will be, that is represented as X1 Y1 line. So it will be like this. So horizontal plane, vertical plane and profile plane. So first quadrant. So horizontal plane is rotated clockwise. Profile plane will be opened outward. It will be opened outward. So intersection of this vertical plane and your profile plane will be represented as X1 Y1 line. Intersection of your vertical plane and horizontal plane will be represented as XY line. So here one more thing that is to be observed is that, so this vertical plane and profile plane will be in line. So you can see this is the horizontal plane. So this vertical plane and profile plane will be in line. So this is how we can draw the profile views or side views. So looking from either right side or left side, we can draw the projections. So this is the problem where we'll be drawing the profile view or side view. Profile view or side view. So once again, going through the problem, it says that draw all the three views. So three views it is mentioned. Which are the three views? Front view, top view and profile view of point P lying 60 mm below HP, 70 mm in front of VP and 40 mm from RPP. So it is right profile plane. Right profile plane. Also state the coordinates in which it lies. So here you have to draw three views: top view, front view and profile view. So first forget about the third part, that is your profile view. Draw the top and front view. We'll try to draw top and front view. So once you read the problem, immediately you should analyze in which quadrant it lies. So here it says that 60 mm below HP, 70 mm in front of VP. Below HP in front of VP. And that is here you can see that below HP in front of VP, both your top and front view will be, that is below XY line. So point is in fourth quadrant. That is clear. So once you know that in which quadrant point lies, then start drawing the projections. So first you will be drawing XY line. So represent X and Y in capital letter. Represent X and Y in capital letter. Then you measure, as it was done in the previous problem, measure distance of 60 and 70. So given 60 mm below HP, 70 mm in front of VP. Below HP in front of VP. That is here it will be like this. Below HP, that is in front of VP. So both, if you rotate horizontal plane, both your top and front will be above your, that is below XY line. So measure a distance of 60 and 70. Locate the point P and P. So since here 60 mm will be corresponding to your front view, this is represented as P dash, and then 70 mm distance is corresponding to your top view, hence it will be, that is top view. So initial first part of the problem, that is similar what we have solved in the previous case, drawing the top and front view. Then immediately show the dimensions. That will be common for all the problems. So extension line as it was shown in the previous problem. So this is 60, this is 70. Then come to the next. First, once you finish this part, first part where you draw the top and front view, then come to the second part. So it says that 40 mm from RPP, that is right profile plane. 40 mm right from right profile plane. So how to draw the profile view? How to draw the profile view? Now already we have drawn the top and front views. So 40 mm in front. So from the projector already drawn, you move a distance of 40 mm. So here this is the projector where you have drawn the top and front view. Move 40 mm towards right. So where from here measure distance 40 mm and draw the x1 y1 line as I shown, that is intersection of vertical plane and your profile plane, that is x1 y1 line. So draw a vertical projector here, name it as x1 y1. Name it as a x1 y1. So since it is given RPP, so this is very much important. What is given, whether if it is on the left side, it will be left profile plane, LPP. So carefully you should read the problem. So since it is given as RPP, so from the projectors what we already drawn, move a distance of 40 mm. So there you draw a vertical projector. So that naming is done as x1 y1, whereas intersection of horizontal and vertical plane is xy, that is already shown. Then here you name it as x1 y1 line. Now here in case of the second quadrant, so one common thing that is you should remember is that, so your top and front view will be below xy line. Similarly, the profile view will be always in the adjacent plane. Whenever the point is in first quadrant, so profile plane will be always in the adjacent plane. When the point is in second quadrant, So here how to draw that is profile view. So always for second quadrant, so the profile will be adjacent to the given that is top and front view. So to draw the profile view, So you see that this is your x1, y1 line, this is your xy line. Intersection, you got point. Intersection where the xy and x1, y1 line intersect. So from that point, you draw a 45-degree line in the adjacent plane. So this is first, this is one plane, this is the second plane, third plane, fourth plane. So in the adjacent plane, you draw a 45-degree line. So from the intersection of your x, y and x1, y1 line. So once you draw the 45-degree line, then the common rule is that always start from the top view, move towards left or right until it meets that 45-degree line, then up or down, then start from the front view, move towards left and right where you will get an intersection point. So this is the common rule, whatever may be the problem. So common rule is that always start from the top view, move towards left or right. So here I know profile view should be in this plane, where that is what I have to locate. So hence I will be moving from this, it is point P, that is top view. So from here until it meets the 45-degree line. So this arrow mark shows in which direction I have drawn the projector line. So I draw a projector line from point P, so until it meets this 45-degree line, then the projector line above or below. I will not go below because I know here I should get the profile plane. So that is, I will draw vertical projector above. Then start from front view. So this point P dash is the front view. So once again draw horizontal projector. Either it should move from left or right. I will be moving in this direction because I know profile view should be here. Where, that is what I am doing to locate the actual position. So I'll draw a projector. So until it meets this vertical plane. So the intersection of this vertical projector and horizontal projector, that is the point where you get the profile view. And profile view will be always represented as double dash. So here the point is given as P. So hence this profile view is represented as P double dash. Start from horizontal plane until it meets the 45-degree line, then draw a vertical projector, then start from front view, horizontal projector, intersection point is your P double dash, that is the profile view. That is the profile view. So this is how we can solve a problem to draw the profile view with the given condition. Next, coming to the next problem. So this is the second variety of problem that can be asked. So like this, the point can be in any of the quadrant. So where it can be in the first quadrant, second quadrant, third quadrant or fourth quadrant, and I can draw the profile view depending upon or satisfying the condition given in the problem. Then come to the next problem. So this is one more problem or one more variety of problem that can be asked. So problem runs like this. Point P is on HP, so very important, it is on HP, and 35 mm in front of VP, 35 mm in front of VP, that is position of point is given, one point is given on HP and 35 mm in front of VP. Another point Q, here we got 2 points. So I will try to draw the projection of 2 points. So another point Q is on VP and 40 mm above HP. 2 points are given. One point P 35 mm in front of VP, another point Q on VP and above HP. Then he says that distance between the projectors parallel to XY line is 50 mm. So this is one more new thing in this particular problem. Distance between the projectors parallel to XY line is 50 mm. Find the distance between their front and top views of the points P and Q. Find the distance between the front and top views of points P and Q. That is how the problem is running. Now, how to get the projectors? So here, if you read the problem carefully, so 2 points are given, point P and Q. Projectors, that is conditions of both the points are given. How to draw the projection? 35 mm in front of VP and that is on HP. Then on VP and 40 mm above HP. So here I will draw the projector on the common XY line. I will draw the projector on common XY line. So first I will draw the XY line, capital X, capital Y. So then take the point P. So it is 35 mm in front of VP and it is on HP. Whenever a point is on HP or on VP, so it will be represented on XY line. So whenever a point is on HP, here in this case it's on HP and point Q is on VP. So it will be on your, that is XY line. So here this point P dash here on XY line, then 30 mm, 35 mm in front of VP. So front of VP means always it will be like this. So 35 mm. So this is horizontal plane, this is vertical plane, 35 mm in front. So this distance will be corresponding to horizontal plane. If you rotate it, always it will be in front, means it will be always below your XY line. So from P dash, that is the front view, you measure a distance of 30 mm. So you locate the position or projection of point here. So that is P, that is your top view, this is front view. Then this is the projection of one point P. Then he has given one more point Q, that is on VP and 40 mm above HP. So in the first problem, it was given that draw the projectors of different points on a common XY line taking convenient distance. So here that convenient distance is given in the problem itself. So 50 mm. So convenient distance here, it is given in the problem itself. He says that the distance between the projectors parallel to XY line is 50 mm. This is the projection of point P. Somewhere I may get projection of point Q. So distance between the projectors. So this is one projector. Somewhere here I will be getting other projector. Distance between the projectors parallel to XY line. This is your XY line. Parallel to XY line is 50 mm. That is nothing but the convenient distance what was given in the first problem. So from this projector I will measure distance of 50 mm. I'll measure distance of 50 mm. So on this vertical projector, I'll try to locate the projector of point Q. So point Q is on VP. So here you'll get the projector on your XY line. 40 mm above HP. So above HP means always it will be above XY line. In front of VP means always it will be below XY line. Above HP means it will be always above XY line. So from this point Q, you measure distance of 40 mm. There you will get the projection of one more point, that is Q dash and Q. So that is, I have drawn the projector of 2 points P and Q. Next he has given something that has to be found out. He says that find the distance between their front and top views of points P and Q. Now this is the front view of point P, this is the top view, this is the front view of point Q, this is the top view of point Q. Distance between their front and top views. So I'll join this front view of P dash and Q dash, so by a thin line. So you measure this distance, that is the distance between their front views. Similarly, distance between their top views, I'll join P and Q. P and Q are the top views. So if you measure that distance, that is the distance between their top views. Find the distance between their front and top views. If you measure this distance, whatever value you get, that is the distance between their front and top views of both the points P and Q.